Let's continue on the linear equation from last time. Let's discuss identifying conditional equations. What does it mean? It means sometimes your equation does not give you a specific solution. Sometimes when you solve an equation, you end up with some statement. There are two cases, contradiction case and identity. So if you solve an equation, it's possible to end up with something like 1 equals to 3, which is a false statement. You might end up with 0 equals to 2. As long as it's a false statement, you can say there is no solution, because you end up with a false statement. There is no possible way that this equality holds. On the other side, you might end up with identity. Identity means you end up with a true statement that doesn't really depend on the variable x. So you'll end up with 2 equals to 2. You might end up with 0 equal to 0, 1 equal to 1. These are all possible cases of identity. If this happens, it means you have infinite solution. Infinite solution. It's possible that every number is a solution. As we go on later, when we discuss functions, there are some cases that not every real number is a solution. But for linear equations, if you have infinite solution, that means every x is possibly a solution. So here, let's look at these two examples. Solve x plus 1 equals to x plus 3. This is already simplified. There is no need to simplify anymore. What we can do is you can subtract the x from both sides by using the properties of the equality. If I do that, what do I get? X minus x is gone. The same x minus x is gone. And 1 equals to 3. The statement dimension 1 equals to 3. This is not a true statement, so this is a false statement. False. So therefore, I can say this has no solution. And if you think about it, look at x as one number. I'm going to use a box to show you. You have the equation x plus 1 equal x plus 3. You have think about x as a box, you have plus 1, and again, box plus 3. Whatever you replace on the box for x, you replace 2, 2 plus 1, 2 plus 3. There's no way that these two are equal to each other. If you're adding a 1 on the left side and a 3 on the right side, the equality cannot hold. You're adding two different values to the same number. So this could never be true. That means this is not true. That's why we have no solution. On the other side, if you look at the other equation, x plus 1 equal to x plus 1, you can think about it already as a box plus 1 equals box plus 1. And you see that this is the same equation on both sides, the same expression on both sides of the equality. Means whatever I replace here, 2 plus 1, 2 plus 1, true. 3 plus 1, 3 plus 1, true. 3.2 plus 1, 3.2 plus 1, all those numbers are possible. It still gives you an equality statement. But if you go through the process, you subtract x from both sides and you want to solve this equation, what do you end up with? These two will cancel out. You end up with 1 equals, these two will cancel out. This is a true statement, so you have infinite solution. Infinite is an I or something. Solution. So what are those solutions? You can say the solutions is all real numbers, because I can replace every number in that real numbers. All real numbers. Sometimes you write it this way, you can write it as R as your solution set. All real numbers. You can just say its solution is all real numbers. I can replace any number that I want for x, and it's still true. Again, for linear cases, it's all real numbers. As we go on, functions and equations become more complicated. There are some cases that you cannot say, even though there are infinite solutions, not all real numbers is the solution. We will discuss that as we go on. So let's try these examples. Start with simplifying. 2 times that, 2 times this, 6 times that, 6 times this. What we get is x minus 2 on the left side. On the right side, I get 6x plus 10 minus 5. And simplify a bit more. 6x minus 2 equals 6x plus 7 plus 5. Sorry. You can subtract 6 from both sides. Minus 6x, not 6. Subtract the 6x from both sides. What you end up with is these two will cancel out. End up with negative 2 equals 5. And this is a false statement. What it means is there has to be no solution. If there was a solution, you will end up with negative 2 equal to 5, which is not a true statement. If I replace any number in here, I should never get the equality. If I replace 1 for x, never get the equality. You can try. Let me show you. For example, replace 1. You can replace 0 if you want. Doesn't really matter. 2 times 3 times 1 is 3. Times 1 minus 1. I'm going to replace it just so you can see. 1 plus 2 minus 5. 3 times 1 is 3 minus 1 is 2. 2 times 2 is 4. Left side ends up to be 4. 1 plus 2 is 3 times 6 is 18 minus 5 is 13. 18 minus 5 is 13. You end up with 4 equals to 13. Not true. It means the 1 could not be a solution. The same every other number that you try will end up with a false statement. You can never have the equality. How about if we try the other example? 4x minus 5. There's nothing to do on the left side, but on the right side you should be able to distribute that to 4x minus 2 minus 3. Still there. You'll have 4x minus 5. Right side is 4x minus 5 as well. You see the same expression. You expect identity, but still go through the process. Subtract 4x from both sides. By doing so, these two can cancel out. These two will cancel out. I'll end up with negative 5 equals negative 5. You can add 5 to both sides, you end up with 0 equal to 0. But this is already an identity. This is a true statement always. It doesn't really depend on the variable x. So what is my solution set? Infinity, infinite solution. Okay, all real numbers. You can try every number and it's still gonna satisfy this equation. It's not any different from solving an equation. It's just that you end up with either contradiction, means something like 1 equal to 3, or you'll end up with an identity 2 equal to 2, 1 equal to 1. In those cases, you have either no solution or infinite solution. Okay, let's discuss solving rational equations. Solving rational equation. What is a rational equation? We know that linear equation have x divided by 2 plus 1 equal to 0. This is considered a linear equation. What is a rational equation? Rational equation means there is a variable in the denominator, at least in one of the terms. So you would have something like 2 over x plus 1 equals to 0. It is not a linear equation anymore since x is in the denominator. But if there is an expression with the variable in the denominator, then you have a rational equation. It could be 2 divided by x plus 1 equal to 0. 2 divided by 3x plus 1. As long as there is a variable in the denominator, you call this a rational expression. If it has equality in it, then it's a rational equation. Now here there are some examples of rational equations. Let's try. First one, 12 over x equals 3 over x plus 3. Similar to what you do for linear equations. If you have fraction, you try to get rid of that fraction. How do you get rid of this fraction? You multiply the LCD of the denominator. What is the LCD of the denominator? X is what they all have in common. This is denominator of 1 if you want. So I will multiply an x to both sides of the equation so I can cancel them. But make sure that these parentheses, there are more than one term, you have to distribute it. So x times 12 divided by x, so we get 12x over x divided as x over 1 multiplies by that 1 times x. X times this term, and the other side x times 3 over x, you'll get 3x over x. X times 3, you'll get plus 3x. So I'm distributing as if it was a number. You do exactly the same thing. Nothing different in linear equation. It's just variable is in the denominator, you try to get rid of the denominator, always. Simplify. 12x over x, you can cancel out the x's. 12. 3x over x, and again cancel out the x's. You have 3 plus 3x. So now you have a linear equation. Solve for the equation. So here I'm going to subtract 3 from both sides. Now isolate the x. Means it doesn't really matter which side the x is on. I'm going to get rid of the other terms. I'm going to get rid of the 3. By doing that, these two will cancel out. 12 minus 3 is 9 equals 3x. Here's something that you can think about the equation like this, but I think most of the students have gotten used to the fact that you always want to have the x on the left side, not on the right side. If you have an equality, always write them in the other order. You can write 3x equals to 9. The same as 9 equals to 3x. Nothing has changed. It's the same as apple equals to orange or orange equals to apple. These two statements, as long as true for one of them, they should be true for the other one. Interchanging 3x and 9 doesn't really make any difference. You still have the equality. So if you want to solve this equation, still possible. It's still okay. But I'm going to stick with the same format just to make sure that if the x is on the right side, you don't get confused. You can always do the same step. How do I get rid of the 3? Divide by 3. Cancel out. So what do I end up with? X equals 9 divided by 3. This is a possible solution. X equals 3 is a possible solution. How do I make sure that it is a solution? Check it back into the equation. So to check, I'm going to use red color. 12 divided by, instead of x, I'll replace 3 equals 3 divided by 3 plus 3. 12 divided by 3 is 4. 3 divided by 3, 1 plus 3. Is that a true statement? Yes, it is. That means I can accept x equals 3. I can accept 3 as a solution. So I'll say the solution set. I can do that. Again, you can solve this equation, 3x equals to 9. It's the same thing. Just rearrange it in a way that it looks easier for you. How about the next equation? What is the common denominator? What do you want to multiply to get rid of all the denominators? If I multiply an x, if I get rid of this denominator, if I get rid of this one, but it doesn't get rid of x plus 1. So what do I need is I need to multiply both x and x plus 1. If I multiply x plus 1, it cancels out this one. If I multiply an x, it will cancel out the other fraction. Whatever I do on the left side, I do exactly the same thing on the right side. X plus 1. By the way, the LCD here is x times x plus 1, or x plus 1 times x. Doesn't really common denominator, x and x plus 1 multiplied by each other. If it was 2 and 3, the common denominator would be 6, 2 times 3. If it's x and x plus 1, same idea. The common denominator is x times x plus 1. So your LCD here is x times x plus 1. Okay, here is what you should be careful. Do not cancel out the terms right away. Do not do this. Do not say these two will cancel out and those two will cancel out. That is not correct. You have to distribute it first. Distribute 2. And think about them as one term. times this as well as times that. If I do that, what do I get? You can give a denominator 1 if you want, just to make sure that you do not make a mistake. 12 times x plus 1 becomes 12x x plus 1. I'm using the parentheses for x plus 1 still. Divide by, denominator is still there, x plus 1 times x plus 1. Minus, if I multiply 10 to this guy, we'll get 10 times x plus 1. Use the parentheses. Divide by, x is still there, 1 times 0. How about the right side? 0 times that. This is the 1 term, by the way. You have multiplication, you can think about it as 1. 0 times that, still 0. That's the beauty of the 0. You don't need to do anything, it just simplifies to 0. Now you can cancel out. I can cancel out x plus 1 and x plus 1. This was the whole purpose. I can cancel out x and x. So what do I have? I have 12x left in this term. Minus, for the other one, there is a 10 and x plus 1. 10 times x plus 1. Close. Okay. Simplify these. 12x, distribute the negative 10 into each term. Times this and times that. Minus 10x. Negative 10 times 1. Minus 10. Close here. Combine like terms, 12x and negative 10x is 2x minus 10 equal to 0. You can do these after a while in one step. So you can say add 10 to both sides, and then you get 2x equals 10. Divide both sides by 2. You'll end up with x equals to 5. Is it the solution? You don't know. You have to check it back into the equation. Not always what you get is a solution. So let's try 5 into the equation. If I replace 5, what do I get is 12 divided by 5 plus 1 minus 10 divided by 5 is equal to 0. This is just to check our solution. 12 divided by 5 plus 1 is 6. 12 divided by 6 is 2. Minus 10 divided by 5 is 2. Is it equal to 0? Yes, it is equal to 0. So what is the solution set? Solution set, it becomes x equal to 5. 5 is the only number that satisfies the equation. If you pick another number and try it, you will see that it doesn't work. If you pick something like 1, 12 divided by 1 plus 1 is 6. 10 divided by 1 is 10. 6 minus 10 is never 0. So the only solution that this equation has is x equal to 5. By the way, in all these examples, I used x, but you can use a different variable. I don't know, for some reason x is a very common one that I use, but you can use w, or here is an example that has y. So let's try these two examples. I'm going to start from the right one. Try this. Right one, left one looks a bit more complicated, but it's the same. Okay. Okay. First, find out what is the common denominator. What is it that you want to multiply to get rid of all the denominators? You multiply y plus 5, so it gets rid of the y plus 5. How do I get rid of the 4? I want to multiply a 4 as well. But by writing it this way, it's not clear what are the terms. So you use parentheses. Y plus 5 is one term, 4 is the other term. I'll multiply it to the left side. Same thing, I will multiply it to the right side. 4 times y plus 5. Make sure that you write this and you use parentheses. You know what is going on. Distribute. Left side is only one term, y over y plus 5. You can give the denominator 1 if you want. 4 times y plus 5 times y is 4y plus 5 times y. You don't need to distribute yet. Simplify first. I'm going to multiply to each other. Multiply across. This one I should distribute because there's an addition. times that, and times this 4. I'm going to put them in order. 4 times y plus 5 times 5 multiplied by the first fraction, y plus 5. And multiply 4 plus y, 4 times y plus 5 times 5 over y plus 5, this is what I get. Plus, if you multiply the second fraction, 4 times y plus 5 is still there, times 5 over 4. 5 over 4. You can put the 4 in the denominator for all of them. Now cancel out, simplify the similar term. Cancel out, y plus 5 will cancel out, 4 and 4 will cancel. Now you see that there is no denominator. So our work has been simplified to simply what is left is 4y. Second term, I have 4 times 5, which is simply 20, plus final term is 5 times y plus 5. Okay, here again you can distribute 5 times y, 5 times 5. At this point it's a linear equation. 20 plus 5y plus 5 times 5, 25. What do you do? Combine like terms, move the similar terms to one side. So here 20 and 25 becomes 45. 5y plus 45. I can subtract 5y from both sides. You can cancel out. 4y minus 5y is minus y. 1y if you want equals 45. So what is y? You can divide both sides by negative 1. Y equals negative 40. This is a possible solution. So what do I need to do? I need to check that solution to see if it really works into the equation. So let's try to replace it back into the equation. I'll go back to the original equation, replace negative 45. Negative 45 divided by negative 45 plus 5 is negative 40 equals 5 divided by negative 45 plus 5 is negative 40 plus 5 over. You can make this last term as a common denominator. Common denominator is 40, so I can make this 50 divided by 40. Same as 5 over 4. This is just so I can add them up and you can see it clearly. Okay, negative 45 divided by 40 is the same as 45 divided by 40. You can use calculator, but in this case it's not necessary. This one is negative 5 divided by 40. I'm just going to write the negative number in the numerator. Plus 50 divided by 40. 50 positive negative 5, that becomes positive 45. Negative 5 and positive 50 is 45. So you have 45 over 40 is the same as negative 5 over 40 plus 5 over 40. This is a true state. You add the numerator and you end up with 45. 45 was a solution. Our solution set. If you're not comfortable with the fractions, you can use the calculator, turn it into decimal, add them up. But make sure that you're using exact value. There is no cutoff. You're checking for solution. Okay, let's try the other example. Space here. Okay. For this equation, we have 11 divided by x squared plus 5x plus 5. The denominator doesn't look to be linear. So maybe your equation turns out to be nonlinear. What do you do? In that case, we haven't discussed how to solve nonlinear equations. But let's try. So let's try, how do we get rid of the denominator? First, try to factor the denominator if possible. You remember factoring? What terms multiply by each other gives you x squared plus 5x plus 4? X and x to give you x squared. X times x gives you x squared. what does it give you? 4, and if you add them up, you get 5. If you look at the other denominator, it's like a hint. 4 times 1 is 4. 4 and 1 becomes 5. This x squared plus 5x plus 4 is basically could be factored into x plus 1 and x plus 4. And on the other side, you still have 3 over x plus 4 plus 1 over x plus 1. I factored this denominator, so I know what to multiply to get rid of the denominator. What do I need to multiply? I need to multiply an x plus 1 to get rid of that. I need to multiply an x plus 4 to get rid of the other denominator. And if you look at the first fraction, it has both of those. So by multiplying an x plus 1 times x plus 4, I can get rid of all these. Make sure you use parentheses. This. And since the right side has 2 terms, I should use a parentheses. So here, multiply that x plus 1, x plus 4 to both sides. You get 11, x plus 1, x plus 4, 14 plus 4. Divide by x plus 1 and plus 4 still there. Multiply this x plus 1, x plus 4 to the first term as well as to the second term. What you get is 3x plus 1, x plus 4, divided by x plus 4, plus 1 times that is x plus 1, 1 times x plus 4, divided by x plus 1. Okay, now simplify. Cancel out the similar terms. What are the similar terms? X plus 1 and x plus 1 can cancel out, x plus 4 and x plus 4 can cancel out, x plus 4 here and x plus 4, as well as x plus 1 and x plus 4. Now you should see that there is no more denominator left. The whole purpose of this multiplication was to get rid of all the denominators. What is left from the first equation? It's only an 11. From the second equation, it is 3x plus 1. From the last equation, 1 doesn't really matter, 1 times whatever is still x plus 4. You can use the parentheses if you want. It doesn't affect anything. No coefficient except 1, so it doesn't really make any difference. Simplify. Distribute the 3. So we get 3x. 3 times 1 is 3. We'll have plus x plus 4. Combine like terms. 11 equals 4x, 3x and 1x, plus 3 and 7, 4, 7. Subtract the 7 from both sides. Minus 7, minus 7. Cancel out these two. You'll end up with 11 minus 7 is 4, plus 4x. Divide both sides by 4. Again, you can switch the x's around, doesn't really matter. You'll end up with 1 equals 3. So what is my possible solution? The possible solution is x equal to 1. But is it really the solution? This is what you need to check. I'm going to check by replacing it back into the equation. Which put it down. Here is replacing 1 into the equation. 11 divided by 1 squared plus 5 times 1 plus 4. You can do those in your head if you're comfortable with the addition. I'm just going to write it to make sure that you understand what am I doing. I'm replacing 1 for x every time I see an x, I replace 1. And where do I replace it? I go back to the original equation. Okay, simplify. 1 squared is 1, 5 plus 1 is 5 plus 4. This is denominator becomes 10. So I have 11 over 10. On the other side I have 3 divided by 1 plus 4 is 5. So 3 divided by 5. And 1 divided by 1 plus 1. So 1 over 2. So now here is you should know how to do common denominators on the right side. Multiply the first one by 2, both in the numerator and denominator, and the second one by 5. So what you have is 11 over 10 equals 6 over 10 plus 5 over 10. 5 over 10 and 6 over 10, it equals to 11 over 10. This is a true statement. So that means that I have a solution set with the answer x equal to 1. If I replace 1 into the equation, I get a true statement. And again, if you try every other number, it will not give you a true statement. By the way, in this example, if your solution for somehow turns out to be -1, if x was -1, when you replace this equation, what you get is 1 divided by -1 plus 1, so you'll end up with 1 over 0. You cannot accept that as a solution. This is why we check our solution, and not say -1 is a solution. Okay? So make sure to check your solutions, see if it really satisfies the equation. Okay, I'm gonna stop here. Continue next time.